All right, everyone, it is the top of the hour, so let's go ahead and start with today's bout of goodness. So welcome again, everyone, to DBA Fundamentals, today with Thomas Grohser on scaling clustered column stores. Today is October 18th, 2022. In the top right-hand corner of the screen, you'll see that all of the list of the leaders of the DBA Fundamentals group: Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. Below that is some of our different social media accounts. First one up is Meetup, probably where you found us today, and hopefully all of our upcoming meetings. So you'll be able to join us there. Below that is our website, dbafund.org, where you can see all of our upcoming presentations and our long list of past presentations. Below that is what we like to call the best part of the internet, the DBA FunTube, where you can watch all of our past presentations, and you can actually subscribe to our channel so that you'll know whenever we put all of our presentations out there for viewage. Below that is some of our other social media from Twitter and Slack and LinkedIn. So be sure to join us on all those so you can catch the latest and greatest. We are recording today's session, and it will be available within 1 to 2 days. Be sure to check us out, like I said earlier, on dbafundtube.com. Also, be sure to turn off your camera and be sure to mute yourself so that we can all pay attention to Thomas and all the goodness that he is going to lay down on us so we know about column stores. Also, be sure to type any of your questions you have into the chat window so that we can feed them off and make this all work smoothly and flawlessly. And with that, I have Thomas's bio, but I am sure Thomas is going to give even a better one out to you. So with that, I turn it over to Thomas.
Okay, so I'll try to share my screen. We'll see how this goes. You should be seeing a little PowerPoint saying scaling clustered column store, and that's what we're going to talk today. So my name is Thomas Grohser, and I'm old. Since I work with SQL since 1994, which 28 years now, and yeah, I'm trying to build the best infrastructure for SQL that I can do for whatever company I work at the time. And in that process, I'll get to test and learn a lot about SQL, and I like to use events like this to share what I've learned. So that's about me. And today, we're going to talk about clustered column store. And up front, if you ignore everything I tell you today, your column store will still work. It will just work way, way slower than it has to. Everything I'm telling you today is how you can help clustered column store to be at its best. Out of the box, if you ignore everything and do the exact opposite of what I'm saying, it will still run. But instead of finishing in seconds or sub-seconds, it will take hours to fulfill its task. And I'm not joking there. Some of the things I'm telling you can cut down execution time by 99.99%. And yes, if there's an urgent question or so, I have no problem being interrupted, but I will stay at the end and answer as many questions as you have after the presentation. So before we begin, a very, very quick one-slide recap on how SQL Server stored data before column store came in. This is how SQL stored data since the beginning of time. You have a row header for each row of data. You have a little header. It's a couple of bytes, nothing major in there, but it tells SQL Server what's coming. And then you have one column after the other with the fixed length columns first and then the variable ones at the end. And this just goes on. And then the second row has pretty much the same format and so on. These rows are put on pages that are currently 8 kilobytes in size, and they are that size for many years. They are in no particular order on the page, but at the end of the page, there's something called a slaughter rate that points to the rows in order. So they don't have to shovel around the data all the time. Something gets modified, they can stay where they are. That saves a little bit of time. The problem with that is that if I just need one column from one row, I need to load the whole page that row is on, and then I can access it. Well, SQL is pretty good at doing that. If you have very wide fact tables and then you have queries that only care about a couple of columns, that's a lot of overhead that can be saved. And this is where column store comes in. So row store is basically, if I need anything from a row, I need to load the whole row, and to load the whole row, I need to load the whole page that has the row on it. That's the thing is. So to read one bit from one column, theoretically, I have to read 8 kilobytes. So that's an overhead of 65,000 bits that I've had to process without needing that. So worst case scenario is about 65,000 times more work than it. That's unrealistic, but it's a nice number to thing is. Never trust the statistics you haven't forged yourself. So column store just flips the way things are stored. So instead of column A and then putting column B, C, and so on together, it stores the value for each and every row in together. Yeah? And then column B, the same thing, and column C. So instead of row by row, the data is stored column by column. And a bunch of these rows that are stored together for each column are called a row group. Yeah? And we will learn the size of this row group on one of the very next slides, so I'm not going into details here, but at some point the row group has the maximum number of rows, and then the next row group is created and looks like the first one, just with different data most likely. Yeah? So column and column. So if I now only need column A, I don't have to load column B or C at all. I can just focus on column A. So in our example, that would already reduce the amount of data I have to process by like 2/3, yeah? Which is pretty significant. Yeah? If I need all three columns, sorry, then of course there's no difference. Yeah? But that's a rare case, and we will see how even in these cases column store will be faster than regular row store. A little bit about column store history. Column store had a little bit of a rough start. Was first introduced in SQL 2012, and you could put a column store index on top of a regular table. Yeah, and this is why it's still called clustered column store index, while technically it's not an index at all. It was on top like any other index, and it was read-only, and indirectly, the moment you put it there, it made the table read-only because you couldn't change the data anymore. And you're like, that's so bad. Like, no, all column stores in every product on the planet are read-only. There's no way to modify a column store. Yeah? And we will very quickly learn how all the vendors go around that. And it's the same with every product. Doesn't matter if you use it in SQL, Teradata, Yellowbrick, ClickHouse, whoever does a column store, when you read it, there's always the little footnote, don't update the data, we can do it, but it's not a good idea. Yeah, we'll look at that more in detail. In 2014, they made it possible they introduced a clustered column store where the column store becomes the table. Yeah, so you don't have the uncompressed version and the compressed version of the data at the same time. Now you only have the compressed version. You can drop that at any time and make it an uncompressed again. Just be sure you have enough space. And insert, update, delete are now possible. Yeah, I'm not saying they should be done, but they are possible. In 2016, you can now also have a secondary column store that's on top of an irregular table as read-write. You can have filtered secondary indexes, and you can have non-clustered indexes on top of a column store. Again, not saying it's always a good idea. I had cases where the column store had like 100 columns and took less space than a single non-clustered index on a single 8-byte column on top of it. It's just the way column store is very good at compressing data, and regular indexes are not. 2017 introduced computed columns. 2019 allowed you to online create and rebuild column stores, which is when you have really big data and lots of it, a very, very helpful thing. SQL, it's not on the slides yet, but SQL 2022, now that the previews are public and everything, and I will go into details on a later slide about the major feature. Column store now lets you specify a sort order. That's the most significant change in 2022. I'll get to that. So the goal for this session is we want to build a column store, a fact table, that returns results quickly, even if we have billions or trillions of rows. So the size, how can we make the size not matter? So let's see why this is the problem. Okay, so solution is we have to help column store. Column store by itself is good in compressing data, but it still needs help of organizing the data in the best possible way so that it can, at any point in time, just work on the data it needs to. Yeah? We must give it a nice physical database where it can exist in. And my recommendation is to have a file group for your column stores. The reason for that, we'll get to. We insert data into row groups as perfectly as we can. We partition the column stores, and many other people will have taught you that in SQL Server, partitioning is a maintenance feature, not a performance feature. And I fully agree, with one exception, and that's column store. And we will look at data types that are much, much more efficient in column store than other data types. Sometimes just changing a data type can make your query faster while you're not actually losing data or any information. So let's talk about the database first. Under the covers, you remember when we said one column, a row group is compressed and then stored? The way it's stored is it's stored in a regular table as a binary large object. So as an var binary max. So it's inserted in a regular table where they can load it out. So they take the large chunk of data, compress it into something small, and then insert it into a single row in another table. And that actually works pretty good. Yeah? Would it be slightly faster if they've written their own engine? Yes. Would there be a lot of problems with it? Probably too. This one works, and it has a couple of advantages. The disadvantage is that whoever ever tried to shrink a database file that has a binary large object or a varchar max or in text or an image on it knows that you can't shrink these files. It takes forever, and the reason is that for every page they move, they have to do a full table scan of the underlying data. So if you have, let's say, a terabyte of column store on there, every time you move 8 kilobytes to a new location, you have to read a terabyte of data. And I've tested it once. In a week, I could move about a megabyte on a 15 terabyte column store. So not an efficient way. When you have that, you can't move that data anywhere. So putting it in its own file group so it's not interfering with any of the other regular tables where you can easily grow and shrink is a very good idea. Yep. So that's what I just said. So plan ahead, put it in its own file group, and your life managing it will be much easier. I usually try to do 12 to 24 data files. That allows me a lot of flexibility, how many underlying drives or file shares or whatever you have to put that. Number 12 is divisible by almost everything. So you can put it on 2 drives, 6 drives, 1 drive, 12 drive, 3 drives, and 4 drives, and can easily balance it out. On 24, just the same thing. So let's go to inserting data and let's start understanding why there is a problem. Yeah? So the perfect way and that's your first new friend that you're going to make today. It's a very magical number, 1,048,576. That's how many rows fit in one row group. So if you have one column, you can insert that many rows, and they will go into one row group. The only way they got into one row group is if you insert that many rows in one go. Okay? So why is it this number? If you take the square root, it's 1,024. So someone at Microsoft thought a good idea, 1,024 times 1,024. Yeah, it's basically a mega row instead of a megabyte. Yes, you can always insert these number of rows again. If you insert less than 102,400 rows, that includes if you insert one row, two rows, whatever you do in with one statement. So if you do a single row insert, then or an insert up to 102,399 rows, what SQL Server will do is not put it into a row group, but put it into a regular row store. They call it the delta row group, which is basically a regular table, and Microsoft just parks it there. And if you never do anything with it, it stays there forever. So if you have a billion rows and you insert them one by one or 100,000 at a time, at the end, you just created a copy of your normal table and took away all the possibilities that you have with a regular table, but you could have put it in a column store. So not the best idea. So if you insert more than 102,400, but not the total number, it works. It will create a row group. It will nicely compress all this. But it will not use the full potential of compression. The reason is compression basically is deduplication, and the more data you have, the more you can deduplicate. The compression is always within one row group. There's no global dictionary or something of commonly used values or so. It's all within a row group. So if you only put half the number of data in, the compression can only deduplicate half the data at a time. So it's less efficient compression. Okay? So this. If you insert more than 1,048,576 rows, it's very simple what happens. SQL will create one row group with that number of rows and then put the rest into a second one where the above rules get applied again. So if you insert 1,048,577 rows every time, you create one perfect row group and insert one row into that shadow table that will catch all the not big enough row groups. Yeah. So the lesson learned here is have some kind of a buffer table where you insert individual rows, and then when you have enough of them, transfer them into the column store. If you trickle the data into the column store, it's really bad. Can it be fixed? Yes. You have to rebuild the column store index. So like you rebuild an index, or you in your index maintenance, here you can do the same. When you do that, it actually cleans up the stuff. The problem with that is one of the techniques I will show you a little bit later will be undone unless you're in SQL 2022. That's why the importance of specifying the sort order is so important. When you insert data, you can also pre-sort the data and help the compression and other optimizations that we will talk about soon quickly. Yes, if you don't, but if you rebuild the index prior to 2022 and don't specify the order, SQL Server picks some random order and might undo all these efforts. So while it will fix all the delta row groups and make them go away and pack everything nicely into fully filled row groups, it will destroy your sort order before 2022. So it's only half a remedy. Thanks, yeah? So the insert architecture I'd like to use is something is creating the data. I do bulk insert API or single row inserts, whatever helps or your system will do. In either an in-memory OLTP table, or if you don't want to use in-memory OLTP, you can even use a regular table, and then have an agent job that waits for that magic number of rows to be there. And once it finds that many rows, it inserts one row group and deletes them from the staging table and inserts them into the column store. With that, I get clean row groups. What I practically do is I don't wait for that for just the number of rows. I wait for that number of rows of a certain kind so that I have this additional optimization I will show you in a few slides. I will mention this then again. And all this is inside SQL Server. The rest can be outside, and there can be many of them in parallel. So that allows you to nicely insert. If each one of these original processes would just insert into column store, the performance would be horrible. Next one, deleting data. In the beginning, I told you column store can't delete, and I'll stand by it. So what happens? Data is not deleted in a column store. What happens is, if you issue a delete statement, what SQL Server will do is it creates another background table, like the one for single rows, and inserts an entry for each and every row that needs to be deleted. And every time in the future you select from your column store, it will have to read that other table and eliminate all the ones that you deleted from the result set before returning it to you. So you basically have to join with that table all the time. Joining with tables that have millions and billions of rows, not a good idea. What you often see in data warehouses, for example, is a technique that for the whole month, so on the first of the month, you insert all your data, and you might even do it like in big chunks that help column store to be efficient. But then on the second of the month, to not have to deal with changes and updates and everything, people delete the whole month and reinsert both days. And then on the third day, they delete the first 2 days and insert all 3 days, and so on. By the end of the month, you have basically your data 31 times. The first day you have 31 times, the second day 30 times, and so on in your column store. And your delete list is also insanely long. If you do this for a couple of years, you have like 10 times the data, and it has to be processed in each and every query. So deleting, very bad idea. But it's not the worst idea. So again, the fix is rebuilding the column store, because then when you rebuild it, you can just skip the rows that are deleted, and they do. But same as before, the sort order gets mangled up. So what's worse than a delete? You're seeing it on the screen. It's called updating data. Internally, whenever a relational database actually does an update, and everybody who has ever written an update trigger knows that an update is basically just a delete followed by an insert. And guess what? If you update a row, what happens? SQL inserts a row into that shadow table that says this row is deleted, and then inserts in the other shadow table. Here's a single new row that I had to add right now. So another example that I've seen, someone nicely inserted 300 million rows in one go, and then ran an update statement to flip one bit to declare all these rows as processed, which basically took the 300 million rows that were perfectly stored in a column store and put it in 2 shadow tables in addition, so that the whole data took, I don't know, 15, 20 times the space, because the shadow tables are not as good compressed, and performance was horrible. So to summarize this, insert in big chunks at a time. You will not always get it perfect, but insert in big chunks. Don't delete, don't update unless you have a plan of cleaning up after yourself. Because if you keep updating and deleting, column store is just not efficient. Update is a delete followed by an insert. Clean up the same as before. You have to rebuild the column store and this. So what about now getting, so we now know if we're not really careful how we get data into column store, it's going to be bad. And now we're going to learn why it's bad. selecting data from column store. Yeah? And this is why it's funny why it was called column store index in the beginning, because technically it's not an index at all. It was just accelerating, if used right, the process so much that it felt like an index, but technically it's not an index, because the only access method for a column store is a full scan of the whole store, the whole column store. So you need to do anything, you need to read it all. And it's not 100% correct, because the detailed one is a full table scan with partition elimination if the table is partitioned. And this is why column store is so important. With all other row store types and partitioning, you can create an index that does the same thing as the partitioning. Yeah? In row stores, you can also use partition elimination, but you can achieve the same thing with an index that does the same functionality. In column store, you can't, because there is no index unless you put one on top of it. And again, that's most of the time a very bad idea, especially on very, very large tables. Yeah? So putting partitions on a column store can help you a lot. Just imagine you partition by day of the year, and most of your queries look at 1 day of data per year. So you just have saved 364 units of your data that don't have to be processed in each and every query. Instead of reading all of it, it just has to read that 1 day. So my advice is always to partition by the most common search argument that narrows down the number of partitions a lot. Yeah. You might not always get it down to 1, which is perfect, but for example, if you partition by day and then you query by month, you're still getting it down from 1 full year of 365 days to 31 days. Yeah? Worst case scenario in a long month. So even then, that's a lot. You're only reading 1/12 of the data, so you're eliminating more than 90%, which is really good. So do that. One trick one thing that you have to keep in mind, not a trick, is there's technically a 12,000 partitions per table limit. But if you look at the interwebs and see what people are telling you, is that once you get above 3, maybe 4,000 partitions, it starts to get a little bit wonky and things happen that are unexplainable. So I would not create more than 3 to 4,000 partitions, which is still good. If you partition daily, you can still put almost 10 years in there, which normally is enough. Very few data sets have more than 10 years. If you partition hourly, you can still easily get a whole year in. So there's still plenty of room. Yeah? Another thing that I learned is that sometimes most people partition by date, because this is very common. Most reports, everything is date-based, so having that is a thing. But sometimes combining several keys might be more efficient. Let me explain what I tried in one case and worked out really well. It turned out most of the queries that we needed from that column store were, hey, give me everything from 1 month and a specific product group. Yeah. So what we did is, instead of having the partitions on the month and then scanning through the whole thing and eliminating all the product groups that we weren't interested in, we decided to create a surrogate key. As you can see down there, in green, we put 4 digits of the year, 2 digits of the month, and then 4 digits in yellow of the product group. And that allowed us to partition by that. We did monthly partitions, so we needed 12 per year. So in 10 was 120, and we had less than 300 actual product groups. So we could stay easily below the 3,000 partition number with that. But when we did the query, we could narrow down the amount of data to 1/20th times 300. So that's 1/30,000 of what we needed to find the data, which if you have a couple of billion rows and you can narrow it down to 1/3000 of it, that's a lot of savings. And when you scan that data, so just an idea, not necessary all the time, might be just enough if you just partition by one of your columns. But keep in mind, you can combine more than one column in a surrogate key and might get some benefit from that. The next step is data types. So while SQL Server really, or column store, can handle each and almost every data type that is there, there is some limits what column store can do with certain data types. So let's get time to find a new friend. The second new friend, again, is a number, and this number is 8 bytes or 64 bits. Every data type that takes 8 bytes or less of storage, column store loves, because it can do a lot of magic with it. So let's see which data types are that. Big, int, small, and float. Binary 1 to 8, character 1 to 8, national character 1 to 4, small money, money, date, date time 2, time. Yeah, that's a lot. Basically everything that's not a text or a reasonable amount of text. Yeah? You can't put any NVAR 200 or something in it because that needs more bytes. But the small ones you can do. What else? So why is that? If these data types are smaller than this or the same size, a lot of the stuff that's in the next couple of slides is possible. If they're not, they work just fine. You can store your data, but it will not show you, it will not be able to use any of the optimizations I show you on the next slides. So the first slide is filter pushdown. We said we can eliminate a lot of data by the partition, which is great. It's the first thing you should do. The next one is, if you have simple filters like betweens, equals, larger than, smaller than, instead of going into each and every row, pulling it out and then filtering it while processing the query, wouldn't it be great if the storage would only return the rows that actually match that filter? And this is exactly what filter pushdown is. In a column store, if the row is 8 bytes or less, if the column is 8 bytes or less, the data type, it can apply a filter while returning the data to the query processor. So let's imagine in a row group, you only have 2 rows that match that filter. Instead of giving you back the 1,048,576 rows, and you have to ignore most of them, it only returns you 2 rows to work with. That is a significant savings for the query processor that doesn't have to deal with hundreds and hundreds of rows. So basically, instead of filtering in the query execution, they can push down the filtering to the query, to the data retrieval from storage. Yeah? But it only works with if the data fits into 8 bytes. Yeah? So the same as filter pushdown, you can do aggregate pushdown, which is even more efficient. Yeah? So often you have simple aggregates like sum, average, min, max. And what if instead of reading a row group, getting each and every column, each and every row for this one column back, and then calculating the sum or the average, what if you ask the storage that has stored it to just give you the sum, average, or min, max, whatever simple aggregate function you can think of, and it will just do that. So instead of returning 1,048,576 rows, it just gives you back one number. And again, that only works on data types that are 8 bytes long. So instead of returning all the rows and the query execution engine does all the math on it, the storage just returns the math. So if you have to sum up the whole table, instead of getting back billions and billions of individual values for each row, you get back one value per row group, and then can just sum this, deal with calculating the final result, which is much faster. Yeah? Again, requires data types to be in the correct size. Besides aggregate pushdown, you can also do something that is called row group elimination. And this is where the sorting that I mentioned before comes in. Yeah? So we can eliminate based on a partition ID, but wouldn't it be awesome if we had a second criteria where we can delete, can have more elimination? And yes, we can. It's called row group elimination. Yeah. For all data types that are 8 bytes or less, what column store does is in the metadata, that's the row that actually holds the data, they have the minimum and maximum value that's inside that row group. Yeah. So if the first row group has the values 1, 2, and 3, hundreds of each one of them, it says 1 and 3. And then if the next one says 5 and 7, 5 to 7, yeah. So if you query and you want the value 2, it only has to look into the first row group and knows that the second row group is not relevant because your value you're looking for is not within the min-max in that row group. You can really help SQL by pre-sorting the data so that lots of data that you want to eliminate on is grouped together and ends up in the same row group. And before 2022, you could not specify that insert order. You could just do it by basically sorting the data and then inserting it in that order. And SQL would not change the order, but why would it add extra work? But if you do an index rebuild, it would change the order to whatever it came up with, which most likely is not what's planned on your side. 2022, this became such an efficient tool that Microsoft decided to put that into 2022 that you can specify that sort order. So that makes it a lot easier to maintain your column store. And it's, again, a very efficient tool because this can be done on a very different column than your partitioning. So you have actually 2 search criteria that can eliminate. And with that, often you can eliminate 99.99% of the data to look at if you park it in the column store correctly. So, yeah, the remedy for that is pre-sort large amounts, and so that a lot of data that is the same is next to each other and can easily be eliminated. Yeah? Fortunately, you can sort by more than one criteria, but usually you very quickly run out of options, and it will only work with one, but you might be lucky. So the last optimization that's there is called batch mode, and batch mode is now coming more and more to row store as well because it works there too. Not as efficient as in column store, but its thing is. The big difference is that for the execution engine that runs the query, instead of working on one row at a time, which basically says, hey, buffer pool, give me the one row. Okay, what's the value? Let's add it to my average. Okay, buffer pool, give me one row. Let's add it to my thing. What it says is, hey, storage engine, give me 936 rows. And the 936 is current implementation. It's somewhere in the ballpark of 900 plus rows. And the explanation for that is the way they do is within column store, the data is basically stored in memory blocks of 64Ks. If you take the 8 bytes per column, you can get 4 parallel streams into 256 bits, which is what a modern CPU can process in one instruction. So you can basically run 4 streams at the same time of data. And what you fit, if you take the 64 bits per value, put them 4 of them together from 4 different columns, you get basically about 900 rows per batch into a 64 kilobyte memory block. And that's why this is about 900. Currently, it's about 936, but if they change any information about the metadata, add a byte here or there, this number will change. Yeah? But roughly about 900 at a time. So instead of going 900 times back and asking for another row to do something, you get 900 in one go, and then they can do 4 at a time with a single instruction in the CPU and add them up, average them, do whatever is necessary to do that. So that makes a lot of sense. In 2022, this will even be more efficient on some types of CPUs. There's still a lot of going on, but stay tuned when it's released. I have to update that slide. Can't share it right now. So what about data types that are larger than 8 bytes? Yep, they work too. You can store a whole city name or the first and last name of people or your product in column store. Just everything, all these optimizations will not be part of your query if you select that column. If you put it in a column and you never query that column, it's not harmful. It just sits there. But if that column is part of your query, a lot of the optimizations cannot happen. Some can still on the other columns. But for example, batch mode is out of the window the moment you have one of these columns because they cannot squeeze it through that pipeline. Right? So that's it. It works. It's there. What I do a lot if I have larger data, considering putting it into an external table and normalizing for it. Depends if it makes sense or not. I had very good success, especially if it's repeating data that just is like the name of a server or the name of a product, and it's the same data over and over again. You might actually be faster here. Thing is, it also depends on your reporting software, how clever that software is, that you could probably create the whole report with IDs, and then the software, when it renders the page, fills in the text, looks up the text, or you have to convince SQL Server to process all the column store stuff, and then at the end merge it with the other lookup tables, because if it does the lookup tables first, you lose the batch processing capabilities again. So where are the limits? Good question. I don't know yet. I haven't found a column store where I couldn't insert more data or where I couldn't process it fast enough. Yeah. So the largest column store I worked with so far is about just over 3 trillion rows. That's a lot of zeros after the 3. It took about 15 terabytes on disk after it was compressed in archive mode. And each original row had 168 bytes of data. If you do the math on that, we compressed 1 to 32. Yeah. To give you an idea, when you do backup compression on most databases, you get somewhere between 1 to 3 and 1 to 7 compression. Here, we got 1 to 32 compression, and we still got a 1 to 2 compression on the backups on it. Yeah. So instead of storing 168 rows, bytes per row, we needed about 5.5 bytes per row, which is really, really not a lot to store 168 bytes of information. But that's what we got. And we could have most queries return in minutes, single-digit minute runs on that whole table with nothing in memory, everything on disk, everything had to be pulled in. But everything, thing is, we did the math. If we would store this in regular row store, it would be 0.5 petabyte, and it would take several hours to scan through every time. Could we have some regular indexes on that? Maybe. But normally when you have fact tables, you are scanning through them. That's how data warehouses work. And yeah, we were really happy that we had the column store. It took us 3 or 4 tries to get this one right, because we didn't follow all the good guidelines I now have in this presentation. This presentation was born out of, we didn't do it, and when we started doing it, we benefited from it. So let me sum it up. Yeah. What we did in this, it's all about reducing the work for SQL Server and helping him to do less. Do you have to do any of this? No, you could just run your query and hope for the best. It's not going to be fun. Yeah. So we inserted the data as correctly as we could. We pre-sorted it so we could get really good things. So we did count, sum, average, min, maxes, all these things where we used aggregate pushdown. We had where, date, and one column A filter. This was the product ID that we put in a surrogate key where we used partition elimination. We had another criteria and column B where we used the row group elimination. This is where the sorting came in within the row groups and put as many identical elements of column B into the same row group. So we get a lot of elimination there. We had another criteria where we used filter pushdown most of the time, and it worked on, again, a small column. We had a couple of columns where we grouped by, and that worked great with aggregate pushdown. Most of the time, SQL could do that and just not bother returning the data at all, just giving us the aggregates per value D, E, and F. And then we managed to optimize and rewrite the queries till they all ran fully in batch mode. And with that, we managed to have all this performance gains. Yeah. So that's everything I found so far in my toolbox of tricks to make column store go as fast as possible. If you have questions, now is the time. Here's my email address. You can, of course, email me afterwards and ask the question if you don't want to ask it in public. But yeah. Any questions?
So yes, we do have one from Lars. Are there any considerations in the NTFS allocation unit size of formatted storage for file groups?
Have nothing to do with column store. That's an advice that's true for every SQL database. NTFS allocation unit size as large as possible. So if you're on Windows 2019 or on Windows Server 2022, make it the 2 megabytes. If you're on anything before that, make it the 64 kilobytes. SQL, when you put SQL databases on a disk, the files will always be large. They will be way larger than 2 megabytes. They will be way, way larger than 64 kilobytes. So you're not wasting space. Where you have to be careful if you choose that allocation unit too large is if you store lots of small files. For example, if you set it to 2 megabytes and then you store a file that is 5 bytes long, you're wasting 2 megabytes minus 5 bytes because it's going to put one file in a 2 megabyte allocation unit. Yeah, but with SQL Server, all files are large. There's nothing small. Yeah, the only time you might have to be a little bit careful is if you do that. What's the name? Where you can put the files inside file. I don't know. There's a way where you can store files inside SQL Server and it's actually stored outside in a directory. That you have to be careful. Everything else, make it as large as possible. There's no reason to hold back. If you have to share the disk with something else that's not SQL Server, doesn't matter because you will not have good performance anyway. So.
Perfect.
Is it worth when you did it wrong to reformat the whole machine and reinstall? No. You get something, but it's probably not worth you spending 2 or 3 days and rebuilding the machine. But for the next one, just pick the largest value possible.
As always. Regarding data types, in Manish's application, they need to eliminate the attributes having a timestamp data type for column store indexes. Is it still available to do that? So you don't have to include some kind of data types going forward within column stores.
Again, you can use any data type that column store will allow you to use. I think it doesn't allow you to use XML and a couple of others, but pretty much everything else you can use. It's just not as efficient if it takes more than 8 bytes per column. that's the gist of it. Yeah, you can use them, and in the result set, it's just fine, but it's less efficient. So sometimes if you can squeeze it into 8 bytes, you might get a benefit.
Yes, Thomas. I mean, yeah, this is Manish with you, and like when we did the POC, I mean, roughly around 6 months ago or something. So that time, I mean, we were using the SQL Server 2017, and I mean, we were trying to convert our couple of big tables. I mean, it was like multi-million rows, all those tables, and there we needed to remove those attributes which are of timestamp data type. So I'm not sure whether that is like now that is now still the case with SQL Server 22, or like that has been
No, timestamp is
been
deprecated for the timestamp data type is deprecated for years. So
okay.
that
Okay, that
should
might
not
be
be
the reason
used to
for
begin
not
with.
allowing. Got it. Got it.
So you can't use text, you can't use image, you can't use timestamp. These are deprecated like 10 years ago. They will never remove them from the product because so many people are using them, but they will not implement them with any new feature.
Got it. Got it. Yeah, and mine is a legacy application, like which is roughly I think 9 or 8 years old or something like that. So yeah, that's good to know. I mean about like usage in that column store indexes. Thank you so much.
Yeah.
Yeah, Thomas, one more question if I still have opportunity to ask. Can I go?
Sure.
Yeah, sure. So Thomas, what is happening is, I mean, in my application, like where we have recently converted around 10 or 12% of our tables, and we are doing a small POC for like what you said to do our daily loads. I mean, daily batch loads and all those things. So that is going in a good, in a good way, I can say, like in a positive manner. At the same time, we are also like a little bit afraid, like when we when the stored procedures, like which is already written like roughly many years ago, like around 7 years ago, as I mentioned. So those stored procedures which will do a joins between the row store table and the column store table. So like can we anticipate any kind of negative impact when joining a column store indexes table? I mean column store table and a row store table, or like
So
will not be like much impact over there.
Joining column store and joining column store table. Let's start with this. Yeah. So there's two different scenarios. You join a column store to any other table.
Okay.
Or you join a column store to another column store. Joining a column store to any other table, as long as you are joining to an indexed column on the other side. Yeah.
Okay.
Preferably the clustered index on the other thing. Yeah. The problem with column stores is while column stores are big, they're never small. So having the option to sort it for a merge sort is not an option for it. So SQL will never consider that. So SQL only has two options: either do scan the column store and do a nested loop to the other table, but that is only efficient if they can grab everything directly from that indexed column that you're referencing. If you have to use an index and then look up the data, that will really be bad performance. The problem is the other one, when they can't do the nested loop, they have to do an hash join, and that hash join means they have to create that hash table. If you ever try to create a hash table on a couple of billion rows, it just doesn't work because MTB is not big enough. So when you join two column stores, the only way you can do that is with a hash join, and you will most likely run out of TempDB trying to do so. And the same goes if you try to join between a column store and something that's not perfectly indexed for a nested loop join. Yep.
Got it.
Yep. It's just, it has to build that hash table, and that while normally you might have some indexes or something on your fact table, you don't have that on the column store. So the column store, they have to go through the whole thing. I've learned that we had an 8 terabyte TempDB, and we could not join more than 1 billion. If the result set had more than 1 billion rows, we could not join to any other table. So for that was just roughly the limit when TempDB said, I'm full, sorry.
Oh,
Yeah,
okay.
it's a very joining column store. Again, it works great if you have lookups to other tables. That works.
Okay.
So if the column store is the middle of a star schema, it works great. If the column store is anywhere on the outside, it will most likely be not a good experience.
Got it. Got it. Yeah. Thanks for clarifying, Thomas. Thank you so much.
Yeah, you're welcome. Any other questions? Going once.
We got lots of
Going
questions,
twice.
as always. Does it make sense to create or update statistics on column store indexes? Because since in most
Always
cases
makes
they
sense.
store huge amounds of data.
Yeah, in the good statistics always help the query optimizer to make better decisions. Never a bad idea to have that. Should you make it excessively? No. Keep in mind, the basic idea of a column store is that you dump in the data and don't change it. So once it's dumped in and you updated your statistics, they shouldn't change much. So the nice thing is that you can do now update statistics partition by partition. If you partition by date, only update the statistics of the current partitions, not the old ones. You don't have to. They do not change. Yeah, if they change, you should consider rebuilding the index anyway, because the only way they can change is by you updating or deleting data, which, as we learned in this talk, will destroy the data structure anyway. So you have to rebuild the index. When you rebuild the index, the statistics get updated automatically. Yeah. So update statistics, yes, on the newly inserted data, not a bad idea. But keep in mind, a good column store is a column store that doesn't change.
All right, and what I think may be the final question, do the 8-byte columns need to be adjacent in the column ordinality in order to take advantage of batch processing?
No, they don't need to be next to each other. So they can be at anywhere. Yeah, every column is stored completely independent from each other. So they on disk, they might be miles apart. They might be in a different data file or so. So they in a row store, sometimes sorting the columns might give you an advantage. Like the first 64 bytes in a row are fetched in the first cache line, and so if you already have your search argument that eliminates the row, they don't have to fetch the second cache line or something. In column store, each column is stored separately. So if you select 4 columns, doesn't matter which ones, they come pumped in, and they get pumped together when needed. Yeah. So doesn't matter if they're next to each other in the definition of the table or not. They are stored separately, so doesn't matter in which order. SQL will pick them, combine them, put them in the 64K, and hand it over to the batch processor.
All right. And so with that, we have actually come to the top of the hour. I know I need to stop just because I have a hard stop right at top of the hour just to do my actual work. But y'all feel free to ask Thomas any questions that you have about dang near anything. I know the man knows pretty much anything he wants about everything with column stores and SQL Server. If you don't believe us, just ask him. Okay. So with that,
thanks.
So with that, I do want to leave y'all. Please be sure to reach out to DBA Fundamentals in the next little bit to see everything that we've got going on. Also, make sure to actually come to our next presentation, which is coming up really soon. It is on November 1st. We have Data Warehouse or Data Lake. Which do I choose? With Rachel Pedeschi. So be sure to come out and join us for that. And remember, if you have any questions or comments, please reach out to Thomas. And so with that, thank you all very much. Have a great day, and we'll talk to you all soon.